All right, good folks. The agenda is on the sideboard, Math 1. We are going to write our homework in our planner. We've already completed the warm-up. Sorry it took an extra long time because I needed to pass back those papers. They've been sitting there. That stack has been sitting there forever, and I just needed to get that done. We're going to work on factoring today. We're factoring trinomials, okay? We're going to factor trinomials. All right. Any questions about the warm up before I move on to something else? Okay, let's write our homework in our planner, please. Let's write our homework in our planner. Do not forget about tutoring on Tuesday and Thursday. We got tutoring today. Ends at 3:10. Make sure that the latest your ride needs to be here is at 4 o'clock. All right, math 1. Make sure that you watch help video if you need it. Don't forget about the tutoring. Make sure you complete your homework and make sure that you study your current notes as well as studying linear functions, okay? Everything on linear functions. Please make sure that you study, okay? Pause for the calls, give you a chance to write. All right, here we go. Yesterday we worked on factor by grouping. I need to go over 7 and 8. I didn't get a chance to do that, so let's do 7 and 8, please. Okay, when you factor by grouping, you always going to look to see if there's a GCF for all 4 terms. Raise your hand if you need me to wait. Anybody still getting ready? Okay, let me pause. Please, let's get ready so we'll know what I'm talking about. Okay, so let's do it. All right, so first thing you're going to look for is to see if you have a greatest common factor for all terms. Okay, if you are lost as to how to do that, you just draw a factor tree for each number. I'm going to write the prime factorization out for each of these numbers. Okay, when I break down 5, it's a prime number. So I can just write 5 times x times x. Any questions about how I wrote the prime numbers for 5? Prime factorization. When I break down 40, draw a factor tree. What 2 numbers can be multiplied to give you 40? 8 and 5. Okay, you can do those. 4 and 10. Circle 5 because it is prime. Break down 8 to what? 2 and 4, and then 2 and 2. So from least to greatest, it's going to be 2 times 2 times 2 times 5 times x. Okay? Negative x, it's a negative, so take out a -1, then times, very good. -8, so take out a -1, and then when we break down 8, it's 3 2s. Do you see how 8 is broken down to 3 2s? 2 times 2 times 2 will give me 8. They don't all 3 have something in common. So you can only factor 2 at a time. Okay? So let's look at the first 2. What do these first 2 have in common? These first 2 terms, what do they have in common? What factors?
X and 5.
They have a 5 in common and they have an x in common. So we're going to take out a 5x. Okay? When we take out a 5x, what can we multiply times 5x to give me 5x squared? What's left?
X.
Just 1x is left. Okay? What can we multiply times this 5x to give us 40x? 8. You see what's left? 2 times 2 times 2, which is 8. Plus 8. The first 2 numbers are factored. Any questions? Okay. Anthony, you okay with that? Right. Let's factor the second 2. What factors do the second 2 terms have in common? They got a -1 in common. Anything else? No. So take out a -1. When you factor out a -1, what can you multiply times -1 to give you a -x? You got an x left. What can you factor? What can you multiply -1 by to get 8? +8. Okay. Now the second two numbers are factored. What do these two factors have in common here? They're both getting multiplied by the same group of numbers. So we're going to put these two numbers in a parentheses together, 5x minus 1. And then we're going to put the number that they're both being multiplied right beside it. These are the two factors. If I was to multiply them back out, I would get this as my answer. Any questions? Anybody need me to wait? No, sit up, baby. All right, so let's do number 2. You look to see if there is a GCF of all 4. If you're not sure, do just what I've done with the others. We got 5x squared, negative 40x, 3x, and then 24. We're going to list the factors. This is prime, so we got 5 times x as the prime factorization for 5x squared. Any questions about how I got this? 40 we did up here. We got 2 times 2 times 2 times 5. 2 times 2 times 2, this is 8 times 5x. And don't forget the negative 1, Ms. Reyes. Let me slide this over. Please make sure to put it in order from least to greatest. I'm going to put that negative 1 in there. All right, 3 is prime. So to write the prime factorization for that is just 3 times what? X. Let's break down 24. What two numbers can be multiplied to give you 24? 6 and 4. Break down both 6 and 4. What about 6? 3 and 2. And what about 4? 2 and 2. So in order from least to greatest, we got how many 2's first? 3 2's. That would give me 8 times 3. Okay? All 3 of them don't have a single term that I could take out other than 1. Okay? So now let's group them. Let's factor the first 2 and the second 2, since we couldn't factor all of them. All right, what can we take out of the first 2? Say again, baby. 5 and x. So we got a 5, and then we got a what? X. So we're taking out a 5 and an x. So take out 5x. What can we multiply times 5x to give me this 5x squared? X. And that's what we have left is this x right here. Okay? What can we multiply times 5x to give me a negative 40x? And this is what's left. Negative 1 times 2 times 2 times 2. That's negative 8. So that's minus 8. The first 2 numbers are factored. Any questions? Let's do the GCF for the second 2 numbers. What factors do these 2 numbers have in common? 3 and what else? Is that it? Mm-hmm. So let's take out a positive 3. When we take out a positive 3, what can we multiply times 3 to give us this 3x? And we see that an x is left right here. What can we multiply times 3 to give me 24? And we see that 8 is left. Okay? How's it?
Because there's x minus 8. And then there's
where is 8x minus 8 at? Where you see that at?
The 5x.
But we're trying to get positive 24, right? You see it?
Yeah.
So this one right here, let me make sure Ms. Reyes wrote it right. I think I wrote it right. I think that we needed an example like this. Yep, that's right. That's written right. All right, so look, when it's like this and there's no way that you can even if you take out a negative, that's going to make this a negative and this a negative. That's not the same. So this is my answer. That's it. That's all, y'all. This is as low as it can go. Okay, and I'm glad we do have an example like this because sometimes that may happen. Any questions?
1 second.
Okay. I'll pause for the calls. Let me know when you're ready, okay? Page 20, right? 21, you're right, sorry. Page 21, factoring trinomials. Q3, page 21, factoring trinomials. We're going to be factoring trinomials where your leading term is 1. We're going to do that first. So where A is equal to 1. And I'm going to show you what that means. We have already started talking about quadratic functions. And remember, a quadratic function, the standard form for a quadratic function, let's write it out. Standard form, quadratic. Remember, a quadratic function are functions that graph U-shaped lines. And the standard form for it is, of course, y is equal to. And you have your first term is an x squared term. Your second term is just the x term. And then the last is a constant. It's a number that has no variable attached to it. Okay? We Q quadratic. Oh. All right. So if you remember, a quadratic function graphs U-shaped lines. A U-shaped line is also called a parabola. Either the U shape is going to be upward, like a smiley face. That means your A term is equal to a positive number. Or it's a downward parabola. This is upward. Let me put upward under here. A downward parabola is where your A is equal to a negative number. This is a downward parabola. I'm going to pause for the calls to give us a chance to write it. So there's only 2 types of parabolas. You got an upward parabola and you got a downward parabola. If your A, the x squared term, is a positive number, then the quadratic function is going to graph an upward parabola. If your A, the x squared term, is a negative number, then your parabola is going to graph a downward. It's going to be downward. The U shape is going to be downward. Okay? Anyone still writing? All right, let me know when you finish, please. All right, so we're going to factor. We're going to factor trinomials where your x squared term is a 1, okay? So we're going to factor these quadratic functions. So we're factoring. Factoring quadratic functions or trinomials, okay? All right, here your A is going to equal 1. All right, first example. We have P squared plus 14P is equal to 48. What makes this a quadratic function? It's a trinomial. Why I say equal? I don't know. So I'm thinking about something else. Why is this a quadratic function? What makes it a quadratic function? Yes. 14p. I said it and then didn't even write it. Why is it a quadratic function? What makes it a quadratic function?
Because P is not a negative.
No, p can be a negative. That means it would just be a downward u. This is an upward u because the coefficient in front of the x squared is a positive number. But what makes it a quadratic function? Because of the x squared term. The x squared term, or which in this case is p squared, makes this a quadratic function. Without it, it would be linear. With it, that's x squared term or the variable squared term is making it a quadratic function. All right, so now we're going to factor this function. When your first leading term is a 1, this is how you do that. Automatically assume that when you factor, you're going to get two binomials. Since it's p squared, you're going to put a p in each parentheses. Please write. So if it's x squared, put an x in each parentheses. T squared, put a t in each parentheses. Doesn't matter what variable it is, that doesn't make a difference. Any questions about that? Okay. After you do that, you're going to multiply the first and the last number together. 1 times 48 is going to give me a positive 48. You are going to think, what two numbers can be multiplied to give me 48, a positive 48? But when you add those numbers together, you get this middle number of a positive 14. Okay, you said 6 times 8. Positive 6 times positive 8 gives you a positive 48 when you multiply. Let's add them together. What's 6 plus 8 equal to? 14. So positive 6 and positive 8 will work. You can put one here, positive 6 or 8, and the other one here. Doesn't matter which one you write first. These are going to be your two factors. If I FOIL them back out, if I multiply those two binomials together, I'm going to get p squared plus 14p plus the 48. Any questions? All right, let's try number 2. Anyone still writing? Are you still writing? Okay, come on, baby. Tell me when you're done. Number 2 is n squared plus 10n plus 16. What makes this a quadratic function? Yes. Very good. N to the second power. That x squared term, the n to the second power, the variable squared, okay, is what's making this a quadratic function. If I were to graph this function, would it graph an upward u or a downward u? Upward. Why? Because the x squared term is a positive number. Okay? All right. So let's factor. Okay? This is a positive 1. So automatically assume that your answer is going to be 2 binomials. Questions? What are you going to put in each binomial? N. Because n times n will give us that n squared. Now we're going to multiply the first number and the last number together. What's the first number times the last number? Hello? 16. Positive 16. That's super important. Now you have to think, what two numbers multiplied together will give me a positive 16? And when you add them together, you get a middle number of a positive 10. 8 times 2. Positive 8 times a positive 2 will give you a positive 16. And when you add 8 plus 2, it also gives you a positive 10. So it doesn't matter which one you write first. You can put plus 2 here and plus 8 here. It doesn't matter. This is your answer. Any questions about that? All right. We're going to do these. Who is that, you know? All right. Let's get those done. All right. So this is what we have. Look. For this one, this is a 1. Automatically assume. Okay. And guys, by the way, I didn't say this, but always look for GCF first. None of these, as you can see, which is why I didn't say it, have a GCF for all 3 of those numbers. Okay. But you automatically always look for GCF. But I knew just by looking at them, I should have said it, that they don't have a GCF other than 1, all 3 numbers. Okay. But GCF always comes first. All right. So now we're going to put a P in each parentheses. You're going to multiply the first coefficient times that last number or constant. Remember, a constant is a number that has no variable attached to it. So that's going to give you a positive 40. So think, what 2 numbers can be multiplied together to give you a sum of the middle number, which is 14? What 2 numbers did you all come up with?
4 times 10.
4 times 10. Positive 4 times a positive 10. When you add the 2 numbers together, it gives you a positive 14. Doesn't matter which one you write first or second. Okay? Any questions? Raise your hand if you got that right. Okay, good. The next one, y'all, please stop complaining. That's why people don't like to do stuff for you, because we complain too much when we do something that's small. Nobody's going to spend a whole bunch of money on a bunch of people that complain all the time. Keep that in mind, please. Can I have your attention, please? Sure, ma'am. Yes. Here in just a couple of minutes. All right, so the first term, the x squared term, is a 1. The coefficient is a 1, so automatically assume that it's going to be 2 binomials, okay? In each binomial, you're going to put an r. In each, r times r is going to give us that r squared. You're going to multiply the first coefficient and the last number together, which gives you a positive 18. That sign is super important. You're going to think, what 2 numbers can be multiplied to give me a positive 18? And I add them together to get this middle number, a positive 9. What 2 numbers can y'all come up with? 6 and 3. Positive 6 times a positive 3 will give me this positive 18, and it will also give me a positive 9 when I add them together. I can put 3 or 6 here. Doesn't matter which one I put first and which one I put second. This is my answer, okay? Any questions? How many people got that right? Perfect. All right, so let's do this one, Samaj, to make sure you understand perfectly what's going on, okay? All right, you ready? All right, so this first number is a 1, right? So we're going to have 2 parentheses. What are we going to put in each parenthesis? P. Good job. We got our table, right? Our little T-chart. What are we going to put here? +7. And we're going to think what two numbers can be multiplied to give us what number we're going to put here. -8. Okay? So we got to think what two numbers can we add together to give us multiply together, sorry y'all, to give us that +7, but when we add, we get a -8. Negative, right, I did, you're right. -1 times -7. Okay, so now when I add those together, I add -1 plus a -7. What does that give us? -8. Good job, babe. So we're going to put -1 here and -7 here. Okay, raise your hand if you got that one right. Perfect. You good? Okay. All right. This first number is a 1. So we got 2 parentheses. We're going to put a B in each. All right. We'll multiply the first coefficient and the last number. That gives us a +14. We think what two numbers can be multiplied. I'm going to abbreviate to give us a sum of the middle number, which is a minus or -9. Any ideas? -7 and -2. A negative times a negative will give us that positive. And when we add these two negative numbers together, it gives us a -9. Doesn't matter which one we write first. -7, -2. This is our answer. Any questions about that? So now I'm going to show you how to do the ones on the bottom of the sheet. We're going to do those. Okay. This is number 7. Same thing. I really hope they don't mess it up for you jokers. We got 3r squared plus 21r plus 30. Okay. So first things first, notice how that first leading term is not a 1. So look, we need to make sure that we do GCF. So what is the greatest common factor for all 3 of those numbers? Yes, 3. We could take out a 3. So when we take out a 3, what can we multiply times 3 to give us 3r squared? R squared. What can we multiply times 3 to give us that 21r? 7r plus 7r, sorry y'all. What can we multiply times 3 to give us 30? 10. Okay. So now, good people, we're going to factor the middle. Okay. All right. So this is a 1 here. So automatically assume, leave this 3 out, keep this 3 down. Automatically assume that we're going to have 2 binomials because we're factoring what's in the parentheses. What are we going to put in each parenthesis? In R. We're going to multiply the first and the last. That gives us a +10. And then the middle number is going to be a positive what? 7. So what two numbers can be multiplied to give us a 10? 5 times 2. And I add those together and I get a what? 7. So I put 5 in one and 2 in the other. And this is my answer. This is completely factored. Any questions? All right, let's put our calculators back. Pick up your cell phone.